In this video, I will teach you how to solve 1- and 2-step linear equations. Now, we learned in the last video about algebraic expressions. Well, an equation is an algebraic expression equal to another algebraic expression. For example, x plus 5 equals 8. Now, the goal of solving an equation is finding the number or numbers that make the equation true when you plug them in for x. So when you were little, you did little math worksheets with problems like this, probably. What number plus 5 equals 8? And you might realize that that number is 3, because 3 plus 5 equals 8. So this particular equation has the solution x equals 3. Because 3 is the number that makes the equation true. Our goal when we solve equations is to get x by itself, or an expression that looks like x equal a number. Okay, so this is our goal. Notice that x has a coefficient of 1, an invisible coefficient of 1 in front of it. There is no number added or subtracted to the x, and it's equal to a number on the other side. Okay, well, the good news is there is only one rule in solving algebraic equations, and that rule is you have to do the same thing to both sides of the equation. The sides of the equation are determined by the equal sign. An equation has a left side and a right side, and you always want to make sure that you do the same thing to both of those sides. So let's write that down. Do the same thing to both sides. Now, people break this one rule down and make it seem complicated. We have something called the addition property of equality, which says that you can add the same number to both sides of an equation without changing its solution. There's a subtraction property of equality. There's a multiplication property of equality, a division property of equality. There's a square root property. There's a power property. But it all boils down to doing the same thing to both sides of the equation. So let's look again at our first example, x plus 5 equals 8. The first thing I'm going to do is separate the two sides of the equation by drawing a line at the equal sign. Now our goal, remember, is to have x equal to a number, which means the 5 has got to go. What can we do to make the 5 go away? What if we subtract it? Now, if I subtract 5 on the left, 5 minus 5 is 0. If you have 5 paper clips and you take away 5 paper clips, you have no paper clips. Now, the rule says do the same thing to both sides, and we can see that x is equal to 3, which was the solution we figured out just using common sense and inspection. Okay, one rule. Do the same thing to both sides. Let's do some more examples. X minus 4 equals 7. Well, I'm going to draw a line at the equals. Now, what number can I add or subtract or multiply by or divide by that would leave us with x equal to a number? Now we have a minus 4, so if we add 4 to it, add 4, negative 4 plus 4 is 0. It makes 0. Negative 4 plus 4 makes 0. So essentially, the 4 completely disappears from the left-hand side. Well, the one rule says that I'm allowed to do this as long as I do the same thing to both sides. 7 plus 4 is 11. and we have found the solution of that equation. X equals 11. All right, next. I have some erasing to do here, apparently. Need to fix that. Okay, so our next example is, let's see, 8 plus x equals negative 12. Now I'm going to draw a line again at the equal sign. Remember, I have to do the same thing to both sides. What I want is for x to be by itself, which means that 8 is the problem. So I'm going to subtract 8 because 8 minus 8 makes 0. As long as I do the same thing to the right side, then I haven't done anything wrong, and the number I get, negative 20, is the solution of the original equation. Next example, negative 3x equals 15. Now, the number one difference with this equation is, notice I'm not adding or subtracting anything to or from x. This time, x has a coefficient of negative 3, and the understood operation between the negative 3 and the x is multiplication. Now remember, our goal is x equal. So to move the negative 3, I can't add 3 because negative 3x and 3 are not like terms, so they can't be added. So let's try division and see what happens. Negative 3 divided by negative 3 is positive 1. And remember, in front of x, there's an understood positive 1. So we found the right thing to do. Now we just have to make sure we do the same thing to the right side. 15 divided by negative 3 is negative 5. Okay, next example. X over 7 equals 2. Alright, this time x is being divided by 7. So I have to figure out what I can do to both sides so that that 7 goes away and leaves me with 1x. Well, in order to get that 7 to cancel out, I need to put a 7 in the numerator as well, because 7 divided by 7, let's write that down, is positive 1. Well, as long as I do the same thing to the right side, I'm fine. Now remember, 7x means 7 times x. So I'm multiplying the left side by 7, so I have to multiply the right side by 7 as well. And I get x equals 2 times 7, which is 14. Okay, I have a kitten on my laptop. Let me move her. How do I fix that? You magical little cat. Okay, looks like I have some more erasing to do. Stop, kitty. Okay, let's do another example. This particular problem is going to be 2x plus 1 equals 5. Alright, this is a very different problem because this time 2 is being multiplied by x, but then we also have a 1 being added to the 2x. So I have two things I have to take care of. I have to get rid of the 1 and I have to get rid of the 2. We're going to try some things. Let's try subtracting 1. What is 1 minus 1? Well, 1 minus 1 is 0, which would leave just the 2x on the left. That seems like a positive move, So let's take 1 from the right side as well, which gives me 5 minus 1, or 4. So I move the 1 successfully by subtracting. And now, since my goal is x by itself, and 2 is being multiplied by x, I'm going to divide by 2 because 2 divided by 2 is 1. Well, if I do it to the left side, I have to do it also to the right side. So I divide by 2 on the right. 4 divided by 2 is 2. And I have my solution, x equals 2. Let's do another example. 4 minus 3x equals 1. I'm going to draw a line at the equals to separate my two sides. Now I don't want you to get too, I guess, sort of routine about deciding what to do with the numbers, and just let your goal steer your work. Your goal is x by itself. The only rule is do the same thing to both sides. Well, I need to move that 4. 4 plus 4 is 8. I don't want an 8, so adding 4 is a bad idea. Let's try subtracting 4. 4 minus 4 is 0. That would leave the negative 3x by itself, and that looks like progress. So because subtracting 4 was a smart move, I'm going to subtract 4 from the right as well. 1 take away 4 is negative 3. Now, to get x by itself, I need to move the negative 3, which is being multiplied by the x. So if we divide by negative 3, we have negative 3 divided by negative 3, which makes a 1, which is what we want. So I'm going to do it also to the right. Negative 3 divided by negative 3 is 1, so my solution is x equal 1. Alright, next example. X over 3 plus 6 equals 4. I'm going to draw a line at the equal to separate my sides. Now remember your goal is x equal when you get down here to the bottom. So just do things that leave you with x alone. So I'm going to subtract 6 because 6 minus 6 is 0. So if I do it to the left, I have to also do it to the right. This gives me x over 3 equal 4 minus 6 is negative 2. Now because x is divided by 3, I'm going to multiply by 3 because a 3 on top of a fraction and a 3 on the bottom of a fraction simplifies to 1. Well, multiplying by 3 on the top worked, so I do the same thing to the right, which leaves me with negative 6. And that's my solution. Okay, we're going to do one more example. I'm going to erase this old work. Okay. Our last example is negative 2x minus 8 equals negative 15. I put lots of negatives in this one, but don't let it trip you up, especially if you have a calculator. Now our goal, recall, is x equal. So we do things that work. Negative 8 minus 8 is negative 16. Check it out on the calculator. Negative 8 minus 8 is negative 16. We don't want to make a negative 16. We want to make a 0. Because negative 8 plus 8 makes 0, adding 8 is the right thing to do. So this leaves negative 2x equals negative 7. Negative 15 plus 8 is negative 7. Because negative 2 is multiplied by x, we're going to divide by it, because negative 2 divided by negative 2 is 1. And since it worked, we do the same thing to the right. Negative divided by negative is a positive 7/2, or if you're using a calculator, your calculator might return the answer 3.5. Okay, so we've learned to solve one-step and two-step equations. There's only one rule. Do the same thing to both sides. Your goal is x equal a number. Thank you for watching.